In this video, we are going to talk about how to write Newton's polynomial in divided difference operator form. So, in the previous video, you saw that if two data points are given, x0, y0 and x1, y1, then we can write Newton's polynomial p1 of x, that is, for the two data points, the maximum degree of the polynomial would be 1 p1 of x a0 plus a1 x minus x0. This is Newton's polynomial of degree 1. Here in this polynomial p1 of x, there are two unknowns a0, a1. Using the two conditions, that is p1 x0 should be equal to y0 and p1 x1 equal to y1, we found these two unknowns, which are a0 as y0 and a1 was y1 minus y0 over x1 minus x0. Now we are going to write this polynomial p1 of x, Newton's polynomial of degree 1, in divided difference operator form. So we defined the divided difference operator like this. F of x0 is nothing but just f of x0, which can also be written as y0. Remember, you write y as f of x. So when there is y0, it can also be written as f of x0. When there is y1, it can also be written as f of x1. Also, if we have two x coordinates inside the square bracket, then by definition of divided difference operator, we can write f of x1, f on the last x, which is x1, minus f on the first x, which is x0, divided by difference between the last x and the first x. The same way we can write f of x0, x1, x2. Inside the square bracket, we have three x's, so we will break them as 2, f on the last two, f on the first two. So it can be written as f of x1, x2 minus f of x0, x1, f on the last two minus f on the first two, divided by the last x, which is x2, minus the first x, which is x0. So this is how we write f of x0, x1, x2. So the divided difference operator is defined like this. Our job here is to write this p1 of x equal to a0 plus a1 into x minus x0 in divided difference operator form. So let's do that. We have p1 of x equal to a0, a1, x minus x0. a0 was y0. We know that y0 can also be written as f of x0. And by the definition of divided difference operator, f of x0 with parenthesis is same as f of square bracket x0. So what we are seeing here is a0 is nothing but f of square bracket x0. So this is the value of a0 in the divided difference operator form. Now we also know the value of a1, which was y1 minus y0 over x1 minus x0. Now we know that we can write y1 as f of x1 minus y naught as f of x naught divided by x1 minus x naught. Now look at this expression, f of x1 minus f of x naught divided by x1 minus x naught. In the notation of divided difference operator, this whole thing is equal to f of x naught x1. See here, we have defined f of x naught x1 as f of x1 minus f of x naught over x1 minus x naught. So we knew the value of a1 was y1 minus y naught over x1 minus x naught. We wrote y is in the f form, and then this expression is equal to f of x naught x1. What we can see here is a1 is nothing but f of square bracket x naught x1. What we are going to do is we are going to put a naught and a1 in this p1 of x polynomial. We have p1 of x equal to a naught is f of square bracket x naught plus a1 is f of square bracket x naught x1 into x minus x naught. So here in p1 of x we have plugged in the value of a naught and a1. Now this is Newton's polynomial of degree 1 in divided difference notation. Why is it in divided difference notation or form? Because now a naught and a1 here are written in the form of divided difference operator. So this is how we can write Newton's polynomial of degree 1 in divided difference form. Let's write Newton's polynomial of degree 2. First of all, we have, let's say, 3 points. x0 y0 1 point, x1 y1 another point, x2 y2 third point. For 3 points, the maximum degree of polynomial will be p2 of x. Degree 2 polynomial. First we write simple Newton's polynomial, which is a0 no factor, a1 one factor, one linear factor. It is p2, so you stop at a2. 2 linear factors. Now one linear factor along with a1 is x minus x0. Along with a2, one linear factor is the same one as was used previously, x minus x0, and next is x minus x1. So this is just the Newton's polynomial. Of degree 2. And in the previous video, we saw that a0 was y0, a1 was y1 minus y0 over x1 minus x0, and a2 was 1 over x2 minus x0 y2 minus y1 over x2 minus x1 minus y1 minus y0 over x1 minus x0. Okay, so we have Newton's polynomial of degree 2, which is p2 of x. Newton's polynomial involves a's, a0, a1, a2. These are unknowns, but in the last video we found these unknowns a0, a1, a2 as described here. Now we have to write this Newton's polynomial of degree 2 in the form of divided difference operator. Now a naught is defined as y naught, and we have just seen here that a naught, like here, is described as f of square bracket x naught. Again, see, y naught can be written as f of x naught, and in the square bracket notation it is same as f of square bracket x naught. Now for a1, y1 can be written as f of x1 minus y naught is f of x naught divided by x1 minus x naught. So this whole expression could be written as f square bracket x naught x1. So we can see that a naught is equal to f of square bracket x naught, a1 is f of square bracket x naught x1. Now we are going to put a2 also in the form of square bracket, means in the divided difference notation, just like we have written a naught and a1 here. So first we will write a2 in the f form. Like in the places of y's, we will put f. y2 here can be written as f of x2. y1 is f of x1 divided by x2 minus x1 minus y1 is f of x1 minus y0 is f of x0 divided by x1 minus x0. This whole expression can be written as f of square bracket x1 x2. Open up this expression and you will get back this minus, and this whole expression can be written as f of x0 x1. Now this whole expression can be written in one compact form in the form of divided difference operator, which is f of x0 x1 x2. When you open up this expression f of x0 x1 x2 square bracket, you will get this whole expression. So what we have seen here is a naught can be written as f of x0 square bracket, a1 can be written as f of square bracket x0 x1, a2 can be written as f of square bracket x0 x1 x2. Look at the pattern that when here it is a naught, on the right hand side you stop at x0. When here is a1, on the right hand side you stop at x1 and all x is behind x1, but there is only one x behind x1, which is x0, so you put x0 here. Look at this a2. It means on the right hand side you will stop at x2 and put all x's behind x2, and the x's behind x2 are x1 and x0, so you have put here. So this is how we write a naught, a1, a2 in divided difference notation. Now our 2-degree polynomial in Newton's form was a naught a1 x minus x0 plus a2 x minus x0 x minus x1. This was the Newton's polynomial. But now we are going to write this Newton's polynomial in divided difference notation, means Newton's polynomial in divided difference notation. So what change will you make? You will only write a naught, a1, a2, which are Newton's polynomial coefficients, in the form of divided difference operator, which are these. A naught is f of square bracket x0, a1 is f of x0 x1, x minus x0, a2 is f of square bracket x0 x1 x2 into x minus x0 into x minus x1. So this is the Newton's polynomial in divided difference notation. Let's write Newton's polynomial of degree 3. First, we are given with 4 data points. With 4 data points, the maximum degree of the polynomial would be 3. So we write P3 of x, Newton's polynomial. Newton's polynomial involves polynomial coefficients which are denoted as a's. Here in this case, the polynomial P3x will be a0, no linear factor along with a0, plus a1, one linear factor, plus a2, two linear factors, plus a3. Polynomial is P3, you stop at a3 and 3 linear factors. Now the first linear factor would be x minus x0. 2 linear factors along with a2. One will be the previous one, which is x minus x0. Next would be x minus x1. Along with a3, the 2 linear factors will be repeated, which are x minus x0, x minus x1, and one linear factor would be x minus x2. This is the polynomial in Newton's form or Newton's polynomial. Here we have 4 unknowns, 4 polynomial coefficients a0, a1, a2, a3. We have to write these a's in the divided difference notation. So we have seen that previously a0 was f of square bracket x0, a1 was f of square bracket x0 x1. So if you have a1, you stop at x1 and all x is behind x1, which is x0, so you have written here. A2 is f of, since this is a2, you stop at x2 and all x's behind x2 are x1 and x0. The same way we can define a3, which is f of square bracket, since it's a3, so you stop at x3 and all x's behind x3 are x2, x1 and x0. This is how we write a's in the divided difference notation. Now we are going to put this polynomial P3 of x, Newton's polynomial P3 of x, in the divided difference notation. So we will write P3 of x. In the place of a0, we will put f of square bracket x0 plus a1. a1 we will write f of square bracket x0 x1 into x minus x0 plus a2 we will write f of x0 x1 x2 x minus x0 into x minus x1 plus a3, which is f of square bracket x0 x1 x2 x3 multiplied by 3 linear factors x minus x0 x minus x1 into x minus x2. So we have written Newton's polynomial in divided difference notation. So here we will write, this is Newton's polynomial of degree 3 in divided difference notation. So to convert a Newton's polynomial into divided difference notation or divided difference operator form, only you have to write a's in Newton polynomial in the form of divided difference operator. So in the next video, we will write Newton's polynomial in the form of forward difference operator. So for that, first we have to write a's in the form of forward difference operator. Then we will put those a's in the Newton's polynomial, and that Newton's polynomial will then be called Newton's polynomial in forward difference operator form.